Okay, so from here we'll start to do the find the vector equation. This is PQ5, passing through A2 -1 5 and perpendicular and intersects the line whose equation is. So the best is always to start the question with a diagram. So it's always very good if you were to start the question with a diagram. So first one, I look at the point, which is 2, -1 and 5. Right, so the vector equation of the line must pass through it's perpendicular and it must intersect the line. It must intersect the line. The equation is x minus 3 equals to y minus 1 over 2 equals to z plus 1 over 2. Alright? Okay, so we are basically trying to find the equation of this line over here. Okay, so how to find the equation? We need a position vector, which we do have, and we need a direction vector. So how do you find the direction vector? To basically, if you want to find the direction, probably one of the things we are considering is that we need 2 points. And to find 2 points, I have 1 point. What I can do is maybe I can find the other point here. Okay, and this point is basically nothing but the foot of the perpendicular of point A to the line. Let me just call this line 2. Okay, maybe I just call this line 2. Okay, and then I call this line 1. Okay, so what I'm going to do is basically now let me just call this point M and say I'm going to find M so that I can get the direction vector for line 1. Okay, so to find the direction vector for line 1, let me find point M, where M is the foot of the perpendicular from A to the line. Foot of the perpendicular goes like that. Okay, so if I want to this basically it's just the, let me look at M. Since M, right, we know it lies on line 2, right? You know, since so-called point M lies on line 2, then you know the position vector OM, right, can be represented in the form of the line. The problem is now this line, right, is in Cartesian form now. Okay, so remember, this is in Cartesian form. So in order for us to make it meaningful, let's try to write it in parametric form. Alright, so I'm sure you have done the conversion by yourself. This is 3, 1, -1 plus lambda of 1, 2, 2, where lambda is real. So this is basically in the parametric form. Yeah, in the parametric form. Okay, so with that, OM can be written as, OM basically can be written as 3 plus lambda, 1 plus 2 lambda, and -1 plus 2 lambda for a particular value of lambda, or sometimes we just write it as for some lambda. Okay, or for some fixed lambda, that's fine also. Okay, then if I say that OM can be represented in this form, next thing we want to do is, because we want to eventually end up with using the dot product of two perpendicular vectors, we find AM, which is the direction vector of line 1. So remember that AM is the direction vector. It gives us the direction vector of line 1. So AM, we just basically take OM minus OA. That gives us, because OA is basically 2, -1, 5. Okay, so AM basically will just get 1 plus lambda, 2 plus 2 lambda, and -6 plus 2 lambda. Okay, then you remember that what we're doing is we're taking AM, we're trying to dot product this AM, the direction vector AM, with the direction vector of the line. Okay, so what's the direction vector of the line? You should remember it's actually 1, 2, 2. It's actually 1, 2, 2. Alright, so direction vector of the line, AM. So since AM is perpendicular to the direction vector of the line, which is 1, 2, 2. Alright, if we dot product the two guys here, it's going to give us 0. Okay, it's going to give us 0. Alright, it's going to give us 0. Okay, this will basically give us 0. And what you do next is just mainly solving for lambda. You obtain lambda to be 7 over 9. Okay, and now we go back to finding the direction vector of line 1, which is AM. So we just sub lambda equals to 7 over 9. Okay, and basically AM, is of this form. You sub lambda equals to 7 over 9. You have 1 plus 7 over 9, 2 plus 2 of 7 over 9, negative 6 plus 2 of 7 over 9, and AM turns out to be, you can write it as A over 9, 2, 4, negative 5. Alright, so you just remember that the AM you are finding is because you need a direction vector. Okay, you need a direction vector. So if you are finding a direction vector, right, we don't have to use the whole vector here. So we can just use so-called the direction vector, just call it M, to be 2, 4, negative 5. That's all right. Okay, so hence the equation of the line passing through point A and perpendicular to the line 2 and intersecting line 2 is basically nothing but R equals to 2, negative 1, 5. Okay, plus a mu of, remember here, 2, 4, negative 5, where mu is basically a real number. Okay, then the shortest distance here, okay, so come back to the question, we need to find the shortest distance now, huh? So what's the shortest distance? You see, it's quite intuitive. I want to deduce the shortest distance. Deduce really also means that it is possible that you are using the earlier part to help me. So this also means that you are using the earlier part. So if I using earlier part, then if I want to deduce the shortest distance, all I need to do, I will just deduce. Okay, so the shortest distance here, okay, is nothing but AM. If you note, the shortest distance from point A to the line L2 is nothing but AM. It's actually just AM itself. So it just boils down to the question, we are just finding the length of AM, which is the length of AM. Okay, to find the length of AM, basically it's just A over 9. Okay, remember, if you're finding the magnitude, don't go and remove the scalar, plus 4 square plus a negative of 5 square, and the answer turns out to be 8 square root 5 over 3 units. Okay,